morning, my YouTube viewers. It is Crystal here. I'm here this morning because I want to do a code review for you, and this is going to be on tweets, and then it's going to be natural language processing, and you're going to predict on how many likes a particular tweet is going to get. Now, this was a Kaggle community competition, and I scored 63 points on it, and the test score was 62 points, so I only scored just slightly lower than the test score, so that's not too bad. I think I was like the only person, well, maybe only one other person submitted their predictions to Kaggle for testing as of yesterday. So we'll see how we go. I'm not going to be working to improve the score because I have other things to do, but I thought it would be nice to do a Kaggle competition and see how well I could score on it, which is what I did. So this is the Twitter likes prediction, and what I will do is I will leave a link to the the Jupyter notebook, so you can look at the Jupyter notebook if you want to. So the first thing that we're going to do is we're going to look at the problem statement, and the problem statement is predict the number of likes for each tweet. So that's what we did. And then after we do that, what we're going to do, after we created our Jupyter notebook is created in the Kaggle website. We're going to import our libraries. So I've been taking a Python course, and the Python course said that you have to import all the libraries at the beginning of the program, but I prefer to import them in bits and pieces, and so that's just what I prefer to do. But according to Python, you're supposed to import everything at the beginning of the program. So it's up to you what you want to do, because obviously I'm not doing it the way Python says you're supposed to do it. But we're going to import the first batch of libraries, which is we're going to import pandas as PD, which creates the data frames and performs data processing. We're going to import NumPy as NP, which creates NumPy arrays and performs numerical computations. We're going to import OS, which goes into the operating system. We're going to import sklearn, which provides machine learning functionality. We're going to import TensorFlow, which creates our neural network. We're going to import matplotlib.pyplot as PLT, which visualizes the data. And we're going to import Seaborn as SNS, which further visualizes the data. So after we have imported our libraries, we're going to use OS to go in and get the files. And when we use OS to go in and get the files, we have 3 CSV files called train, test, and sample submission. So after we have retrieved the files, then what we're going to do is we're going to use pandas to convert those files into data frames. So the data frame names are train, test, and submission. So now what we're going to do is we're going to look at the train file. So your train file has a keyword, likes, and tweets. There are not any missing values in the train files, which is good because I don't have anything to deal with or impute. Now we're going to check the test file, which you have an ID, you have a keyword, and a tweet. So we check to see if we have any null values, And no, we don't have any null values, so we don't have anything to impute. And then we check the submission. So at the submission, you want the ID and the number of tweets. So now what we're going to do is we're going to analyze the target. But basically what happened was I tried to do a disk plot on it, and the SNS Seaborn disk plot, and that didn't seem to work. And then so what I did was I tried a matplotlib histogram, and I only had like one column of data to represent the zeros, and I did my best and I couldn't get the histogram to work. And so I just did value counts. So you can see that the 0 was the highest value of 65,573, and then you had 1 of 24,388, and then it goes on down. So to where you had only one like tweet, or it goes on down to where you had 21,545 tweets, okay, or likes. So now what we're going to do is we're going to get tweets. So train tweets equals train keyword plus space plus train tweets. And test tweets equals test keyword plus space plus test tweet. And now we're going to define our X and our Y. So your Y is your target variable, and your X is train tweets, and X test is test tweets. So now what we're going to do is we're going to use sklearn's train test split to split the X and the Y variables up into training and validation sets. And so we've done that, and you can see in the shape of X train, X val, Y train, Y val, and X test. Now we come up to TensorFlow, and so we're going to import TensorFlow and its associated libraries or associated modules. And we got a warning, but we're on TensorFlow 2.12. So now what we're going to do is we're going to convert the pandas datasets to TensorFlow. So xtrain ds equals tf.convert to tensor xtrain. And you do the same thing to xval, ytrain, yval, and xtest. So now we've got xtrain ds, xval ds, ytrain ds, yval ds, and xtest ds. So now what we're going to do is we're going to vectorize the phrases. So your maximum features is 10,000, sequence length is 250, and text vectorizer equals layers dot text vectorization. Standardize equals lower and strict punctuation. Max tokens equals max features. Output mode equals int. Vocabulary equals none, and output sequence length equals sequence length. So now what we're going to do is we're going to fit the features into the text vectorizer. So features equals train, xtrain ds, text vectorizer equal text vectorizer dot adapt features. Now we're going to get the vocabulary, and what I did was I asked the question on Stack Overflow on how to use TensorFlow to remove the small words, and nobody replied. I did get an answer one time saying that TensorFlow isn't really designed for natural language processing, but TensorFlow, it does have some natural language processing, but you can't get the small words out of it. I wish that you could get the small words out of it. If any of my viewers know how to get the small words out of a TensorFlow tensor, please let me know, and I will certainly do it. We create a function called preprocess, and it returns text vectorizer, and then we encode the first 3 examples of xtrain ds just to give you an example of how it works, so you can see how xtrain ds works. And now what we're going to do is this is just an example as well. For n in range 3, you print the original tweet, and then you print the tweet after it's been vectorized. So number 1, the original tweet is Elon Musk, freedom is priceless, Twitter files Brazil, and round trip it says Elon Musk, freedom is priceless, Twitter files Brazil. And what it does is it made it lowercase, and it stripped all the non-alphanumeric characters. So now what we're going to do is we're going to define our recurrent neural network. So model equals tf.char sequential. Text vectorizer is your first layer of the model. tf.char.layer is embedding. Input dim equals len. Text vectorizer, get vocabulary. Output dim is 128. We're going to use masking to handle the variable sequence length. Mask 0 equals true. And so tf.char.layer is bidirectional, and tf.char.layer is LSTM 128. tf.char.layer's dropout is 0.2. tf.char.layer's dense is 128. Activation is read loop. tf.char.layer's dropout 0.2, and tf.char.layer's dense is 1. Activation equals linear. Then we do a model summary, so you can see a summation of the model. And now what we're going to do is we're going to compile the model. We're going to compile it on loss is mean squared error, optimizer is RMS prof, and metrics is MSE. Then we're going to set it up for early stopping and MC, model checkpoint. Now what we're going to do is we're going to fit the data into the model. So history equals model.fix, xtrain ds, ytrain ds, epochs equals 10, validation data equals xval ds, yval ds, batch size equals 32, callbacks equals early stopping MC. And then we go val loss, val accuracy equals model evaluate, xval ds, yval ds. So I only set it up for 10 epochs because it took such a long time to train it. But when we set it up for the valuation loss, we had 244794 as the MSE. Now what I've done is I've created a plot of the loss of the model, and you can see the loss of the model here. And now what we're doing is we're predicting on xval ds. So we're going to flatten ypred equals model.predict xval ds, and then ypred equals ypred.flatten ypred, so you can see ypred. So now what we're going to do is we're going to check our mean squared error, and we're going to get the root mean squared error using sklearn's mean squared error function. And we have a root mean squared error of 494. So what I do now is I create a plot, and I compare the actual values against the predicted values, so you can see that. And then I create a data frame of the actual values against the predicted values. So now what we're going to do is we're going to predict on our test set. Predictions equals model predict x test ds. predictions equals predictions dot flatten, and then predictions. And then I create a disk plot of the predictions so you can see what the predictions are. And then after I've obtained the predictions, then what I do is I put the predictions in the submissions column likes, and I convert the submissions data frame to a CSV file. And so this is the CSV file that it's been converted to. It's got its IEG and it's got its likes. And then what we do after we do that, we have to save the model, and then when you save the model, you can view it, and then you can check your output, and then you check your output, and then you submit the submissions. And whenever I submitted these submissions, I got 63.23926. So if you want to go onto the leaderboard, we go into the leaderboard. It says we've got 3 teams. So, yeah, so one person did lower than me. I did 63, and then the plus 1 participant did 62, and 3P did 70. And if you want to come over here to code, well, I'm the only person who shared my code, because a lot of people won't share their code. The reason why they won't share their code is because they don't, well, you know, they want to be winners. They're not team players. Let's just put it that way. They're not team players, and they want to be winners, and they think that if they share their code, then somebody's going to score better than them. So, but I share my code because I'm a content creator, and because I'm a content creator, I share my code for that reason. But that's the way, if you want to win a competition, you have to study other people's codes to see what they did. And I actually did it the day before yesterday. I was working on an images, and then I didn't know what to do, so I had to look at people's code to try to figure out what to do. And then sometimes that's the only way you're going to learn, is to look at other people's codes. So sometimes I do have to look at other people's codes, especially if I'm covering a topic that I'm not really secure about, then I have to look at other people's codes. But as you can see, I made my code public, but the other 2 people, they didn't make their code public. So I'm going to go ahead and close this video because I've covered the code review, which is what I intended to do. So I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. If you want to be notified whenever I make a video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my code review. I look forward to making more code reviews for you in the future.